Hello children, welcome to my channel Chemistry by Ms. Nidhi Banga. Today we will be talking about chapter number 4, Carbon and its compounds. In this chapter, I've already made 3 videos. There is video on isomers, all 10 reactions of the chapter, and soaps and detergents, right? So in today's video, I'm going to focus on questions on carbon, all the reasoning questions, then electron dot structures, homologous series, and functional group. So today is the part 1 of carbon and its compounds. After that, I'm planning to make one video on competency-based questions also. So let's get started. Okay, let's begin with reasoning questions based on carbon. The first question is, why carbon doesn't form ionic compounds? Or other way to say the same thing is, why carbon does not form C+4 ion or C-4 ion? Or why does carbon form covalent compounds? 3 questions, 1 answer. So, carbon we know has atomic number 6. So, its electronic configuration becomes 2,4. That means it has 4 valence electrons. Now, to attain stability, it can do 3 things. First option is to lose these 4 electrons. Okay, in that case, it would be left with just these 2 electrons, which means completely filled first shell. Okay, that it can do by losing 4 electrons, and in doing so it will form C+4 cation, right? Or it can gain 4 more electrons in the second shell. In that case its configuration would be 2,8 because 4 electrons are there already. Then it would form carbon -4 ion by gaining 4 electrons. Now the third option, we'll talk about it in a while. First let's see why these 2 options are highly unlikely. See, to lose 4 electrons, a lot of energy is required. Why? Because electrons are very tightly held by protons in the nucleus. There are 2 electrons here and there are 4 electrons in the next shell. All these electrons are facing a pull towards the nucleus because there are positively charged particles present in the nucleus. There are neutrons also here, but right now we are not showing them because they are insignificant to understand this concept. So these electrons are facing a pull towards the nucleus. In other words, these protons are sort of holding these electrons, right? Now, if you want to remove these electrons, we need to give energy to overcome this attraction. Then only we can pull the electrons. To pull 1 electron, you require some energy. To pull 2 electrons, you would require more energy. To pull 3 electrons, you would require even more energy. And as you can imagine, to pull 4 electrons, a lot of energy would be required. That is just not possible. So it's energetically unfavorable situation. Energetically unfavorable. Okay. A lot of energy is needed. That is why this does not happen. Now, why can't carbon then gain 4 electrons? Because gaining 4 electrons is also not easy. See, 6 protons are holding 6 electrons, right? If you add 4 more electrons in the picture, it's going to be very difficult for the 6 protons to hold now 10 electrons. Okay, so that is also very, very unlikely. That is also does not happen because 6 protons cannot hold 10 electrons. Right? That is why these 2 things don't happen. What happens then? Carbon prefers to share electrons. Okay? And in doing so, it forms covalent compounds. Covalent compounds are formed by sharing electrons. See, co means together. Okay? So, co-teachers means the teachers which are sharing responsibilities. Right? So, covalent bonds are formed by sharing the valence electrons. Covalent is sharing valence electrons. Okay, this is how you remember it. All right, so now I hope I have answered the 3 questions, right? C+4 is not formed because it's energetically unfavorable. C-4 not formed because 6 protons cannot hold 10 electrons. What option are you left with? Sharing of electrons. That is why carbon forms covalent bond. So, the next question is, why does carbon form large number of compounds? or state 2 reasons for versatile nature of carbon. The 2 reasons for versatile nature of carbon, or why the carbon forms a large number of compounds, is first catenation, and the next one is tetravalency. But first let's talk about catenation. What is catenation? Catenation is ability of carbon to form bonds with itself. Bonds with itself means other atoms of carbon. Okay, that it does because carbon-carbon bond is very strong. So, carbon can form bonds with itself to give long chains of carbon, branched chains of carbon, and even rings. So see, carbon can form long chains of carbon, right? It can even form branches, okay, and it can even form rings. So see how the versatility of carbon is there because of its ability to bond with itself. So variety is possible because it can bond with itself so strongly that it can form long chains, it can form branch chains, it can even form rings, right? This ability is because carbon-carbon bond is very, very strong, okay? Carbon can just forms rings and chains and side chains, but it can also, the variety increases because it can also form multiple bonds with itself. Like carbon-carbon double bond is also there, carbon-carbon triple bond is also there, apart from carbon-carbon single bond. So now imagine if you have if you have 6 carbon atoms, the possibilities are endless. You can make a compound with 6 carbon atoms in a straight chain, or you can have a shorter chain and add branches to it, or you can have it in the form of ring. You can play around with chains. You can have 2 branches, you can have 1 branch, you can have 2 branch on the same carbon, you can have 2 branch on the different carbons, or you can have double bonds, 1 double bond, 2 double bonds, 1 triple bond, 2 triple bond. So the number of compounds formed by just 6 carbons would be a lot, would be endless because of all these things, because of ability of carbon to form multiple bonds and form chains and branches and rings. Okay, all this is because carbon-carbon bond is very strong. Next is tetravalency. Tetravalency, as the name suggests, that it can make 4 bonds. Carbon can make 4 bonds. Okay, so it can make 4 bonds with itself, with 4 carbon atoms, or it can bond with hydrogen, oxygen, nitrogen, sulfur. Okay, it can bond with many atoms, chlorine, fluorine, bromine. That also increases the number of carbon compounds that are possible. Okay, now that all is possible because carbon can make 4 bonds. Imagine if carbon could make only 2 bonds, then obviously the number of carbon compounds would be limited, because in that case carbon would only be able to form a chain, not branches, right? So carbon can form many compounds because it can form 4 bonds, it can form multiple bonds, and it can bond with itself, and it can bond with other atoms as well. So all these basically under 2 topics, catenation and tetravalency, are the reason why carbon can form such a large number of compounds. Okay, so next question is, why does carbon show catenation? Which other elements show catenation, and to what extent? Why does carbon form strong bonds with most other elements? Alright, so why does carbon show catenation? Because carbon-carbon bond is exceptionally stable, is very stable. Why is it so stable? Because carbon size is very small. It's not the smallest, but it's very small. So what happens if the size is small? If the size is small, let's say this is 1 carbon atom, this is the other carbon atom, okay? They are sharing electrons, right? And let's say this is the nucleus, okay? If the size is small, the distance between nucleus and electron is not much. In that case, nucleus is able to hold on to the shared pair of electrons. Nucleus is able to hold on to shared pair of electrons or shared electrons. Okay, but what if the size is larger? If the size is larger, let's say this. Okay, these are the electrons and these are the nucleus. Now see, nucleus is far from the shared pair of electrons. So the nucleus won't be able to exert as much pull. It won't be able to hold on to these shared pair of electrons very strongly. Okay, that is why this bond would be weak. Okay, bigger atoms means longer bond length. Longer bond length means weaker bonds. Okay, this is bond length. Longer the bond length, weaker is the bond, because nucleus is far away from the shared pair of electrons. Therefore, it's not able to hold those electrons very strongly. Okay, shorter bonds are stronger bonds because nucleus is closer to the shared electrons and therefore can hold on to those electrons much more strongly. Okay, that is the reason why carbon shows catenation and why carbon forms strong bonds with most other elements. It's because of the small size of carbon. Right, now talking about which other elements can show catenation. There is sulfur and then there is silicon. But the extent is not much. It's up to 7 to 8 atoms in a molecule. Beyond that, the molecule becomes highly unstable and breaks. For example, there is S8 molecule. In S8 molecule, sulfur is bonded with other sulfur atoms in a crown-like shape. Okay, so this is the extent of sulfur showing catenation. Beyond this, sulfur cannot show catenation. Silicon also cannot show catenation beyond 7 to 8 atoms because their sizes are bigger. So the bonds become weaker. All right. So this is the reason why carbon can show catenation, but other elements not so much. Okay, next question. Why do covalent compounds show low melting point and boiling point? Now, I'm drawing a covalent compound involving carbon. Now here, I'm not drawing the whole compound. Okay, let's say this is one compound which has carbon chain here and here and here and everywhere. So this is one molecule of that compound. There is another molecule here. Okay, this also goes on. So what I'm trying to show is one covalent molecule, another covalent molecule, right? So what happens is when you are trying to melt a solid or when you are trying to boil a liquid, what you are doing is you are breaking the interaction between two molecules. You are not breaking the bonds here, here, or here. You are breaking the interaction between molecules. And this interaction in case of covalent compound, this intermolecular force between the covalent molecule is very weak. Okay, that is why a little bit of energy is enough to break this interaction and pull the two molecules apart so that they resemble the arrangement of a liquid. Okay, so why do covalent compounds show melting point and boiling point? Because the intermolecular force is weak. Okay, please know that what intermolecular forces are. The forces acting between two molecules, and these are the forces which are broken when anything is melted or boiled. You do not break these bonds in melting and boiling. These bonds are very strong. We just learned that carbon-carbon bonds are very strong. Okay, it's the interaction between the covalent molecules which are weak. So I hope this much was clear. Okay, so the last question is why covalent compounds are bad conductors of electricity. For electricity to flow, we need charged particles. Charged particles in motion. Okay, like when we have ionic compounds, they furnish ions in aqueous medium, that means when dissolved in water, or in molten case. That means when they are given enough heat to separate cations from anions, so they both can move freely. Okay, that is when ionic compounds conduct electricity when the charges are free to move. But ionic compounds can furnish charges because they are made up of cations and anions, right? Covalent compounds, on the other hand, cannot furnish ions because they don't have ions. Covalent compounds do not have free ions or electrons. Okay. Electrons are also charge carriers or current carriers, but they are current carriers when we are talking about metals. Okay, in metals, the charge carriers, the current carriers are electrons. They move, therefore metals are also good conductors of electricity. Covalent compounds do not furnish ions or electrons, therefore they do not conduct electricity. Okay, now let's review very quickly. Carbon compounds or carbon does not form ionic compounds or C+4 or C-4 ions because small size? No. Energetically unfavorable? Yes. It's energetically very unfavorable for carbon to form C+4 ions or C-4 ions. Therefore, it does not form ionic compounds. Carbon forms large number of compounds. It's because of the tetravalency and catenation. Shows catenation or forms strong carbon-carbon bond or forms strong bond with other elements. It's because of the small size of carbon, which leads to strong carbon-carbon bond. Then low melting point and boiling point, that can be attributed to weak intermolecular forces. Poor conductor of electricity, no free ions or electrons. Okay, next topic, homologous series. The simplest question that you can be asked from this topic is, what is homologous series? And you should know the definition. Homologous series is a series of compounds where one compound differs from the next compound by a CH2 unit or 14 U mass. Okay, let's see the example. The simplest series, it's a series of compounds, so there has to be at least a few compounds. Let's say we have methane, then we have ethane, then we have propane, and then butane. Okay, if you notice, they all differ from each other by CH2 unit. That means one carbon and two hydrogens are extra. Okay, so they differ from each other by CH2 unit and or 14U mass. This 14U mass is mass of the CH2 unit. Okay, so this is homologous series. That's it. You just define it and give one example. Important thing to note is that it's not just possible in alkanes. It can be any functional group. You can have a homologous series of alcohols, of carboxylic acids, of ketones, of aldehyde. Okay, as long as the next compound differs from the previous compound by a CH2 unit, or if we are talking about mass, then the mass would be different by 14 units, 14U, right? This is homologous series. Characteristics of homologous series, very simple. First, that they have to have the same functional group. If the functional group is different, they cannot be from the same homologous series. For example, if you have HCHO, that is methanol, CH3CHO, CH3COOH, and CH3OH. Let's say this is the group of compounds. You have to choose the compounds which belong to the same homologous series. Now, this is aldehyde functional group, this is aldehyde functional group, this is carboxylic acid, this is alcohol. So these two are from different functional group altogether. So they cannot belong in this series. And see, these two, everything else is same except an extra CH2 unit here. Okay, so these two belong to the same functional group or same homologous series. But these two do not belong in the same homologous series. That is one point. Second point is, since they have the same functional group, they have same chemical properties. That means they will react in the same way since they have the same functional group. Okay. What about physical properties? Physical properties along a homologous series show gradation. Gradation means show a gradual change. Physical properties like melting point, solubility, it changes as the mass changes. Okay, and mass obviously changes in a homologous series. Every next compound gains a mass of 14 unit. So as the mass changes, melting point changes, boiling point changes, even solubility changes, right? So there is a slow change in physical properties, okay, but the chemical properties remain identical, remain the same. Okay, these are the characteristics of homologous series. Now, next is select the HCs means hydrocarbons. Hydrocarbons means the compound carrying only carbons and hydrogens, which belong to the same homologous series. Give name of each series. So, we have here some compounds and we have to select the homologous series for each. Now, before that, let's give you a quick recap of alkane, alkene, alkyne, because these are all hydrocarbons, and in hydrocarbons you have three classes: alkanes, alkenes and alkynes. Alkanes, general formula CnH2n plus 2. Everything following this formula comes under the category of alkanes. Alkenes, general formula CnH2n, they have a double bond, minimum one double bond, and everything following this formula comes under alkenes. Then we have alkynes. They have a general formula of CnH2n minus 2. They have carbon-carbon triple bond. Alkanes have only single bonds, right? So let's see. CH4, if you keep N as 1, you would see that it follows alkanes, general formula. C2H2, it follows alkyne. C2H4, this is alkene. C2H6, alkane again. C4H10, alkane again. C3H4, it would be alkyne. C3H6, it would be alkene. Okay, so these two belong to one homologous series. These two belong to one homologous series. This is missing one compound. So this does not come in the series. Alkynes, these two also come in the same homologous series, right? It belongs to the series, but it doesn't differ from the previous compound by only one CH2 unit. Okay, there's a compound missing, which should have been C3H8. Okay, all right.